Section 2.5, it's multiplication of real numbers. Begins on page 93. Couple of goals: multiplying real numbers using properties of multiplication, and then solving some real life problems with them involved. The sign of a product is going to be negative if it has an odd number of negative factors. This is easier said to say that if they're different, if the signs are different. Signs are different when you're talking about two things. It means one positive, one negative, or one negative, one positive. Or in this case, it says if it has an odd number, that means if you're talking about three or more than two things that are multiplying by each other, if it's an odd amount, they'll be negative. If it's an even amount, it's going to be positive. This means if they have the same sign. So even means they have the same sign. So again, this is only talking about same sign. This is only talking about when you're multiplying two things by each other. This sign, the things that are in the box, is when you're talking about multiplying more than two things by each other. More than two or more than three, I should say, three or greater. Example number one says multiplying real numbers. 2 times 3 is 6. Both of them are positive. Neither one, that means they have zero negative factors, so it's going to be positive. B says 7 times negative 7 times negative 8. Notice there are two negative factors, two of them. That's an even amount, so it's going to be a positive product. 7 times 7 is 49 times 2 is 98, a positive 98. C deals with 5 negative factors. 5 negative factors. That's an odd amount. If you need to write that out, you can see it written out. Negative 2 to the third power, we know, means negative 2 times negative 2 times negative 2. So that's how you get 3 of them. And then the other ones say negative 1 to the second power, negative 1 times negative 1. That's how it means 5 negative factors. 5 means it's going to be a negative value. 2 times 2 times 2 is 8. Times 1 is 8. And since it's 5 of them, an odd amount, it's a negative 8. D says 2 negative factors is going to make it a positive. Negative 3 squared times negative 5. It says in example 1D, be sure to understand that negative 3 squared is not the same as negative 3 squared in parentheses. This is a very common mistake. Negative 3 squared is not the same thing as negative 3 squared. The difference is you're only squaring what's right next to the exponent. So it's as if it would look like that. That would be 3 times 3. The one that's in parentheses would actually be negative 3 times negative 3. Very common mistake I see a lot. And the reason that it's going to be positive is because you have two negative factors, negative 3 and negative 5. 3 times 3 gives you 9, and that times 5 is negative 45 becomes positive 45. Then now we have variable factors, not dealing with just numbers or just values. Now we have unknown values, or what we call variables. Two negative signs. It holds the same rule. That's why we talk about an odd amount versus an even amount. This has two of them. That's an even amount, so it's going to be a positive x times y. This has two negative signs as well. Negative times a negative means a squared. Anytime you are multiplying the same base by each other, and we'll talk more about exponents as we go, but the same base, like let's say, for example, a times a. Let's just leave the negatives off for a second. A times a. Everything is being raised to the first power. So anytime you're multiplying the same base by each other, you add the exponents 1 plus 1. So this would be the same thing as a to the 1 plus 1, and that's how it comes out to be a squared, or a to the second power. A negative times a negative just means that it's going to be positive at the end because it's an even amount. Then negative 9 times negative a times negative b. 3 negative signs, you can count them up. You can see there's 1, 2, 3 negative signs. So it's automatically going to be a negative sign. Negative 9 times a times b, or negative all of those, will just be negative 9ab. You can't do anything with a or with b since you don't know what those values are. So it simply would be written as negative 9ab. Example number 3, checkpoint. finding the product, negative 1 to the 5th power times negative 3. So right here, if you had to write them out, you don't need to, but if you had to, you know that this would be the same thing as negative 1 5 times. 2, 3, 4, 5. And then it's multiplying times negative 3. So if you count how many negative ones you have, we know that this is 5 of them because we wrote 5 of them. And then this makes 6. That is an even amount. 1 times itself, it doesn't matter how many times you do it, it's still going to be 1. And 1 times 3 is going to be a positive 3. Since it's an even amount, it's going to be a positive value 3. 2 says simplify the expression. 6 times negative 8 t times negative t squared. So we have how many negative exponents? That's what we want to see. How many negative factors, not exponents. This right here, ignore this for a second. Just looking at this part right here, the parentheses doesn't mean it's the same thing as negative t squared. You can see that that's not what's written there. That says negative t and the square is written right next to it. So this is not the same thing. So negative t squared means it's to the 2nd power. We're multiplying a negative times a negative. There are 1, 2 negative factors, so it's going to be that's an even amount. It's going to be a positive. It's going to be positive at the end. Multiply 6 times 8, and you get 48. Again, it's going to turn out to be positive. And multiply t times t squared. That's the same thing as t to the 1st times t squared, which gives you t to the 1 plus 2, and we're going to get 48t to the 3rd power. So that's 2 simple things you have to do there. Just multiply 6 times 8, and then add the exponents. 1 plus 2 gives you t to the 3rd power. And again, since there were 2 negative factors, negative 8 and negative t as it's written up there, it'll be a positive value at the end. Properties of multiplication says the commutative property, just like properties of addition, commutative just moves. A times B becomes B times A. It commutes from one spot to the other. So 3 times negative 2 is the same thing as negative 2 times 3. That's all commutative is. Associative acts just like the associative property of addition. A times B first, then times C is the same thing as A, and then B times C first. The parentheses are just moving from one group or one association to the other. So negative 6 times 2 times 3 is the same thing as negative 6, and then 2 times 3 first. You're going to get the same values. The identity property acts just like the identity property of addition. Except remember, with the identity property of addition, you were adding 0 to something. But the identity part stays the same. If it's A at the beginning and it's A at the end, which it looks like here, it's A to start and it remains A, its identity doesn't change. So it multiplies by 1. 1 times negative 4, it's negative 4 to start and it's negative 4 to finish. That's the identity property. With the properties of addition, we were just adding 0 to it. The property of 0, however, is it becomes 0. So A times 0, notice it's A to start, but it becomes 0 at the end. Same thing with negative 2, it becomes 0. Just to compare that to the properties of property of 0 when you're adding, we added the inverse of it. That would be like, say, an A plus negative A. That's what we said to make the property of 0 with addition. A plus its inverse or negative A. This is just multiplying by 0 to get 0 for the product of 0. And then the product of opposites says the product of a number and negative 1 is the opposite. So negative 1 times the number A, which we don't know its value, becomes negative A. Negative 1 times the number negative 3, notice it becomes positive 3. That's the opposite. We understand what opposites mean. That's the opposite of negative 3. So that's the property of opposites. Evaluating a variable expression says evaluate the expression when x's value is negative 3. So the first thing you're going to do is you're going to substitute the value negative 3 in place of x. So in place of x, simply plugging in or substituting negative 3. The second step, you need to do your exponents first. You need to evaluate the power. You need to do uh, E before you do MD in your PEMDAS acronym. So -3. Now notice it's in parentheses now. Anytime you substitute something in or you plug something in, you treat it as if it goes inside parentheses. Now it's -3 times -3, which gives you a +9. So you're left with -2 times a +9. That has an odd amount of negative factors, or there's only one negative factor, so it's going to give you a negative value at the end, and 2 times 9 is the value 18. When you have 4 times -x squared, again, x's value is -3. The first thing you're going to do, just like on the first problem, the first thing you're going to do is in place of x, you're going to plug in -3. But notice it says negative x. So it's 4 times negative, and then x's value is -3. So you wind up with negative in this case. You wind up with negative here, and anytime you have negative, that changes to positive. That's like multiplying a negative times a negative, it gives you a positive. So what you wind up with is 4 times +3 squared, because that was what's inside parentheses first. You have to do what's inside parentheses before you do the exponents. So now you have 4 times 3 squared. Evaluate the power 3 times 3, and you get 9. And then 4 times 9, we know, is 36.